Dear students, greetings from Dr. T. Sendil Murugan, Associate Professor and Head Department of Information Technology, Kakatiya Institute of Technology and Science, Warangal. In this video lecture, we are going to discuss about doubly linked list. In previous video lectures, we have discussed about what is linked list, advantage and disadvantages of linked list, array and linked list differences, and singly linked list, circular singly linked list with its operations we completed. In this particular video lecture, we are going to discuss about what is doubly linked list, how we can create the doubly linked list, what are the operations we can perform in the doubly linked list. Those topics we are going to discuss in this video lecture. So dear students, this is week 9 lecture 2, classroom discussion topic 26, doubly linked list. So before starting this lecture, we must be discuss about course outcome, like lecture outcome of this particular lecture. After completion of this lecture, student will be able to develop a C program to create nodes in doubly linked list and perform insert and delete operations. So what is doubly linked list? Doubly linked list are two-way linked list. We can say doubly linked list is considered as a two-way linked list. Okay, singly linked list or one-way linked list or one-way chain we told, but here doubly linked list is considered as the two-way linked list. Okay, it is more complex type of linked list because we have both the forward and reverse direction of pointers. Okay, so if it consists of three parts, so previously we know the each node have two part. One is the data part, another one is the next pointer where the next node is pointing it. So in this doubly linked list, we have three portions, three part. First part is previous node. Okay, so address of previous node, and center portion is the data part, and last portion is as usual next part. Okay, so three parts are there. In structured linked list can be given as how we are creating it at using this code. Okay, so the previous we know we have these three part, these two part we know that how to write it, structure node. Here we are adding only one line extra for create the previous node. The pointer is pointing to the previous node. That only we are one line we are added extra for creating the node. If we are adding this, the node will be created like this. Okay, so this first portion will be this asterisk of previous. Sorry. So here center portion, this data portion will be here, and this portion will be asterisk next. Okay, so whatever the node we are created, in case if we are allocated memory as a new node means, so we know that new node of previous pointer, new node of previous, this is this portion. Okay, new node of data, new node tends to data portion, that is center portion. This one is new node of next node, new node tends to next, this portion. Okay, so three portions we know. After using this structure concept, we have the memory will be allocated like this. So see here, this is the doubly linked list. Here the first initial node and last node have the null pointer. Initial node of previous node, last node of next pointer, both will be null pointer because so there is no next node, here there is no previous node. Okay, so in between this, here this is pointing to next node of the current node, this is pointing to previous node of the current node. Okay, the previous field of the first node and next field of the last node will be null pointer. Okay, so previous field is used to store the address of the preceding node that enable us to traverse the list the backward direction. But at the same time, doubly linked list call for more space per node, more expensive basic operations. Why? Because it will have forward and reverse direction, as well as each node have to maintain the address of previous node and next node. Okay. So advantage of doubly linked list is we can search the element twice as efficient. Okay, so forward direction or reverse direction, immediately we can perform it. So here you will just see this. Previously we have that memory portion have only two. One is data part, another one is next part is there up to single linked list. Here we are added one more field is previous. So as usual, we know that start pointer or head pointer is pointing to the first node of the linked list. The hello world again HELLO. So we are storing the characters in different memory location. This is considered the memory addresses. Memory addresses. So here you see that the first node of previous node is null pointer. So always we can mention null is equal to -1. Okay, that's why we are mentioned -1. Then last node of next portion is -1. Last is O. That last of next portion is -1. These two are null. Okay. So remaining, where is the next character is stored? Okay. Next is third position, that is E. But where is the previous value H is stored? That is 1. Okay. These two are interchanging. Now, first two characters. Next, second and third character. Second character stored in the third location, and before this character stored in the first location, and next character is stored in the sixth location. Like that, we are making this linked list. So this is a pointer how it is pointing to the node in the memory location. So now we will insert new node in the doubly linked list. So we know what is doubly linked list, how to create the doubly linked list, and what is the advantage of doubly linked list we are discussed. Now we are going to perform the insert operation in the doubly linked list. So what are the possibilities are there? We have four possibilities. Okay. So first one, insert at the beginning of the node. Already list is there or not, we have to check. If list is there means what we have to do if we want to insert at the beginning. Same like that, insert at the end, what we are going to do. Insert after a given node, insert before a given node. We will give one node, before that node how to insert, after that node how to insert. Those four topics we will discuss under the insert operation. The first operation is beginning. Okay, so how we are insert the node at the beginning. Suppose we have the linked list, we want to add a new node with the data 9. So how we can perform? So you consider this is a linked list we created, doubly linked list we are created. Start pointer pointing to the first node. Start pointer of first node of previous pointer is pointing to null, and last node of next pointer is pointing to null. Okay. So now we are creating the node, new node. So whenever we are creating the new node, that will be inserted at the beginning means the previous node of the beginning node is null pointer. That's why we initially we will give. So in case we will consider this is the new node. Okay. So this is the new node. So how we can write the code for this new node of tends to previous portion equal to null. We are assigning null value. Then new node of tends to data part. Data part is 9. Already we are given 9 or value you can give. So these two are over. Okay. After creating the MLX function, this structure will be created. So initially we are assigning two values. So now we can assign this value only. What is this value? Start pointer is pointing to first node, no? So now whatever the pointer start of next. So how we can say that this one, this portion start of next portion. Okay. So this portion is start of previous portion. So whatever pointing to here, start of next portion, that will be there, but before this we are inserting no start pointer. So what we will do, new node of next portion is, what is that, start pointer, whatever it is pointing the first node, start pointer. So simply we can write start pointer. So what we will do finally, this node will be the start pointer. So start equal to, after assigning start value, start equal to new node. Okay. So these four steps we are going to do now. Okay, so initially start pointer is there, it will pointing to here. So how the algorithm is there? First we will check memory space is there or not. If memory is not available, simply you can print overflow. If memory is there means you can avail pointer, that memory will be allocated to the new node. Okay, so the new node is created now. So the avail pointer pointing to where the free space available in the next free pool. Okay, so up to 3 it will be considered as the memory. So now we are going to consider the node. So what is that? After creating memory, what will be happen? This part is created. Okay, new node of data, it should be value. So what we are written already written in the previous slide. New node of data means center port. Whatever value we will give, that will be stored here. So next, new node of previous. So that is the first node. So automatically we will give null pointer. Okay. So now new node of next. So this is the first node now. Again, whatever start pointer is pointing, that node will be the next node. So this portion, what we will write? Start node, whatever pointing we are given. So the new node is attached with that node. So finally, start pointer pointing to this node. So start equal to start node of previous pointer equal to new node. Okay. So finally, we will change start node equal to new node. Okay. So this is over. So now end of the linked list. What we will do? So if now you just consider, I want to create the node again. So for this creation, we know that available memory we will check. If memory is not available, you can print to overflow. Otherwise, you can avail will be for new node. Then avail will be pointing to the avail next. Up to 3 steps, it's the same. So next we will create the node. We are created. This is the new node. Okay. So we can attach this node here. So what we will do, this is the last node we know. So end of the portion means new node of next portion will be null pointer. New node of data portion will be value. Then here we don't know what is the last node. Last node address should be keep it here. So what we will do, we will use one pointer. This pointer will move up to last node. So the pointer is pointing to here now. Okay. Up to null pointer, the pointer will move. So once it is null pointer, pointer is pointing to the last location. So what we will do now? So whatever PTR is there, no, that PTR is the new node of previous portion. Here we will write that new node of previous portion equal to PTR. PTR value we are assigned. What happened? This node is pointing to here. Will pointing like this. Now PTR of next portion. What is that PTR of next portion? PTR of next portion is equal to new node. So because last we are added new node. Okay. So what happened? We are created node. Simply we are removing this portion. We are allocating the new node address. This address, this PTR will be assigned to new node. So these two code will be used to attach the last node of the pointer. So see here we are created the memory. So now we are creating the PTR as the start pointer. PTR will move up to last node. So after moving this, it will attach with the last node. Whatever I said, it is there. You will check the memory. If memory available means we are allocated to memory for new node. The avail pointer will pointing to the next free location. So 3 step will be related to allocating memory. The next new node of data, whatever value we will give, that will be assigned. New node of next part is null because it is the last node. Then PTR is moving to initially it will start from start node. The PTR next not equal to null means the PTR pointer will move to PTR next up to it will reach the null pointer. So these 3 steps, these 2 steps are looping statement. The PTR pointer will move to last location. Once it is moved to last location, then we know that new node of previous is PTR and PTR of next equal to new node. These 2 lines I written in the examples. I hope you are understood how we are insert at the last position. Now insert the new node after a given node. How we can perform? Same like that. We have to check the memory. Memory is created means we will find that value, which value they are given. So initially the pointer is created to first node, then it will move up to the given node. So now they are given the value PTR equal to value. If whatever value you are given, after which node has to be inserted. So here you want to insert the new node. So after this given value, so PTR is pointing to this node. So up to that node, PTR will be moved forward direction. Now it is showing the current node. After this node, we will insert the new node. Okay. So now we are creating the new node. So that will be insert after the pre node. So what is the procedure? We will check it now. How we will do that. So initially, first three steps are common. We know that memory allocation. So new node we will create it. So in this new node of data portion is value. We are assigned that value over. So initially the pointer will pointing to first location. It will move up to third location now. So here this diagram you see here, PTR is pointing to this location. Last portion you just see here, last portion. After that PTR will move up to whatever number you are given. PTR tends to data. So that means whatever data, if you are given value 3 means PTR tends to data equal to 3. Up to this point it will move. Okay. So this loop will be moved PTR to current node. So after that what we are going to do? New node of next equal to PTR of next. Why? You see here, PTR is moved here. We have created the new node. So PTR of next, this is the next portion. So this portion will be pointing to here. Why? Because this node already pointing to this is the node. So the same address we will assign to new node means this link will be established. Okay. This link will be established. And new node of previous equal to PTR. So once we are given this link will be created. Okay. So now what is the pending is there? So new node portion is over. This portion is over. So this portion PTR of next equal to new node, and here what will be there? This pointer PTR of next PTR next means this node. So in this node, the previous portion will be the new node. This portion will be the new node. So new node means this address will be means this link will be established. Okay. So what we are did, new node of previous pointer is PTR because the current location it is pointing. PTR of next means that next portion of the current position node, that is new node. So what we will do last after that node, PTR of next of previous node. So what is that? This conditions you just consider this one. PTR already pointing here. Okay, so this portion is PTR next. It is pointing to this node. Okay, so PTR of next, that is this node. Okay, PTR of next. This is PTR. This is PTR next. Okay, PTR next node. So in this node, this portion, that is previous portion. Okay, that is previous portion. This portion is the new node address equal to new node. Okay, so this is the code we written in the slide last step. So everything is over. Okay, so now insert before the given node. What we will do? So we will create the memory. We will get the data. Up to that data, we will move. We are create the pointer. Initially, pointer is pointing to the first node. Then pointer will move up to the move PTR further. So it's now points to the node whose data is equal to the value before which the node has to be inserted. Okay. So in case you are given the data is 3, value is 3 means before 3 PTR will point. So after creating this new node, how we can insert it? PTR is pointing to here. So we will see that algorithm. So initially first 3 steps are same. Memory we will check. So now we are creating the new node. So this new node of data portion is value, that is similar. Then PTR is start from the first pointer, it will move up to given number value. PTR tends to data. Okay, so here tends to missing. PTR tends to data not equal to num. Up to that pointer will move with the point next. So these two steps are loop statement that PTR will reach to current position, like whatever value we are given up to that node. Before that node, we are inserting the new node. Okay. So for that, what we will do, new node of next portion is PTR. Why? Because before this node we are inserting. Okay. So here one node is there. Here another node is there. So we are inserting this node. Okay. This is the new node. So this is now PTR is finding. Okay. So PTR finder, what it is there. So we can insert this one now. So whatever PTR is there, that is the next portion of new. Okay. So new node of next is PTR. That is the line we are written. So next new node of previous. What is that? New node of previous. Whatever the PTR previous is there, no, that we will give as new node of previous. So now the link will be established like this. Okay. So next PTR of previous. So what is the PTR of previous? This node. Already we are assigned here. This node will be new node. So that is we are written like this. Okay. So now this link will be established. Okay. So now PTR previous node of the next portion. PTR pointer this one. PTR of previous already pointing this node. So PTR previous means this node previous of next portion, this portion. Okay. So next portion equal to new node value. Okay. So this is now the node is inserted. Okay. So now all four conditions we are checked. Insert at the beginning, insert at the last, insert at the before the node, insert at the after the node. So now deleting a node. So delete also we have that four cases same. Delete at the first node, delete at the last node, delete after a given node, delete before a given node. So first delete the first node. What we are going to do? So here you will see this is the linked list. We want to remove this node. Okay. So what we will do? Simply you can remove this. So the start pointer will pointing to here. So what we will do? This node as a start of next. This node is start of next portion. Is this is the next node. Okay. So the start equal to start next. We will find it. What we will do? Start equal to start next. That means the start pointer will pointing now this node. So now start of previous is null. Previous equal to null. Why? Because this node there is no previous node. Now I am changing this. Start of previous equal to null pointer. So start pointer pointing to this. Start of previous node is this one. So now it is free. So what we will write? One pointer we will create for removing this memory. So PTR we will assign, then free PTR we will write. Okay. So this is the step we will do. Just we will see step by step procedures. Okay. So now start pointer is pointing to the next node. Simply we can remove the memory of first node. So what is the step? First initially the list is there or not we will check. Start is null means there is no node in the linked list. So simply we will create one PTR. So pointer for the starting node. Then start pointer will be start next. Start of previous node equal to null. So finally we are making the PTR will be free. Is deleting the first node. Last node means what we will do. So I want to remove this node. So this node I want to remove. What I have to do? So pointer we will create one pointer. This pointer will move up to last node. Okay. So pointer of previous node. This node. This portion is pointing to this node. No. So PTR of previous node is it is pointing here. Okay. PTR of previous of next. We can write like this also equal to null pointer. Okay. If you are kept like this, null pointer will be pointing here. Then this PTR is pointing to here. No. So simply we can write it free PTR. So this node will be removed. Will be considered the last node. So this is the step. We will see the algorithm, how it is there. Okay. So we can create the PTR here. So PTR will move to last node. So now PTR pointing to the last node. So now the PTR pointer, whatever previous null is there, that will keep the null, then this last node will be removed. See the algorithm. What we will do, initially we will check empty list or not. If it is not empty list, we will create one pointer. The pointer will move to last node. Okay. So for this, we are using this loop statement. PTR will move to last node. Okay. So once it is reached the last node, PTR of previous PREW and that PREB. Okay. So you will keep that one. Of next portion is null. So I told you previously same thing it is there. So now delete after a given node. So if the value is 4 means after a given node. So this node is there, no, after that node 7 will be there. So we can remove this 7. How we can remove the 7? So PTR will move up to 4. So after moving this, what we will do? So whatever address is there, that we will keep it here. Okay. So whatever address is there, that will keep it here. Okay. So what will be happen now? If you are keep this address means this node will be pointing to here. After changing this node will pointing to here, and this node will pointing to here. This link will be established. In between 7 will be removed. Okay. So same like this happened here. You just see. So algorithm will check. Okay. So first 3 line empty list or not we are checking. If empty list means simply print the underflow. Then initially we will create the pointer. Pointer will move up to given number. So these 2 lines are pointer will move to current position. Pointer moves to current position. Whatever value you are given as input. So then you will create one temporary pointer. The temporary pointer is assigned to PTR of next. Why? Because that node we have to free memory. Memory we have to remove. For that reason, we are creating one temporary pointer. So then PTR of next equal to temp of next. Whatever temp next is there, that we are assigning to the PTR next. And temp of next equal to PTR value. Okay. So that after this, we can free the temporary memory. Before a node, what we will do? If in case I will give the value 4, before the node means 3 will be removed. So PTR will move up to here. So now PTR is pointing to here. So what we will do that if PTR is pointing means here means this address will be stored to here, and whatever it is stored here, whatever values are stored here, this value is there, no? This is for next node. Okay, sorry. So what we will do if we want to remove this node means this node will pointing to this node. Okay. So this node will pointing to this node. So where we will take, so this value we will assign to here. This value we are assigning to here. If you are doing like this node will be removed. Okay. So PTR is pointing here. So simply PTR is there. This node will be removed. So again, temporary pointer they are created. First one it is empty list or not we are check. If it is not empty list means we are create by PTR that will start from first node. It will reach up to given number. Okay, so these two are looping statement to reach the current position. So after that we are creating one temporary pointer. That pointer is pointing to PTR of previous node. Okay, so what is the PTR of previous node? PTR of previous node is this portion. So this is stored as the temporary. Okay, so now what happened? Temp of previous of next node. Temp of previous of next node. Temp of previous of next node means temp of previous means this is the node. Okay, so previously it is there. Of this portion, next portion will be assigned to where we are assigning PTR pointer. So where the PTR is there, this pointer is there, no? There it will be assigned. So this node will pointing to this location. So in that location we are assigning PTR. So after assigning, temp pointer will be freed. Okay, so here seventh step, somewhere it is missing. So where it is after assigning this value, we can change this value. What is this? That previous pointer of previous node of the next portion is PTR. Okay, so that we are assigned here. So now we are completed insert operation. Insert at beginning, end, before the node, after the node. Delete also the same 4 operation we are deleted with discussed with algorithms. So now this is the reflections part. So the algorithm I given, you just answer for this question. Okay, so there is a given space is there. The answer is same like that. Okay, so PTR tends to next not equal to start means it will go. Okay, so up to last node. Once it is reached there, then it will find this one. So we are discussed about doubly linked list with examples, operations of doubly linked list with examples, and algorithm of each operation we are discussed. Based on the algorithm, you can write the program for the concepts. Okay, so now you have to create 3 nodes with a doubly linked list and insert and delete a node in front and last of the list respectively. Also display the each operation. Okay, so now we are completed the lecture. So end of this lecture, having completed this discussion on circular linked list and doubly linked list of its operations, the students will be able to, okay, doubly linked list and its operations. Students should be able to develop a C program to create nodes in doubly linked list and perform the insert and delete operations. Okay. So further doubt, you can refer 6.4 doubly linked list in Rima Tareja reference book. Further doubt, we will discuss in the classroom discussion. Thank you very much for listening this video with patience. Thank you all.